this presentation, we'll get more practice with binary files. To do so, we'll finish Tutorial 13, Exercise 2. In that exercise, there's two functions that you'll need to write. One is called createFile. It is similar to a function that we wrote in a previous tutorial where you'll write an array of integers into a binary file. The next function is called tripleValues, which takes a stream that's open in input and output mode, and you'll read the integers, triple their value, and then write them back to the same file, using binary file operation. By doing these exercises, we'll also get practice with random access in files. I will cover the solutions to both functions in the next slides, so if you haven't done so yet, please complete Exercise 2 of Tutorial 13 before proceeding. Here's the solutions for createFile. The function is required to write the given array that I call nums into a file using binary writing operations. There are a few things to remember when dealing with binary files. The first is that when you open the file, here I'm creating an output file stream called numbers.bin, you need to pass in iOS binary as the second argument of the constructor. So because I'm opening in output mode, I give iOS out, and then the bar tells it to combine the mode with iOS binary. So it's being opened in output mode and binary mode. The next thing is when we're dealing with binary files for output, we'll use the function called write. And recall that the first argument is a pointer, and it's a character pointer. The reason why it's a character pointer is because binary files deal with everything as bytes, and a character has a length of 1 byte. The second argument is how many bytes you want to write, and that's usually obtained through a call to the sizeOf operator, which will tell us the size in bytes of the argument given to it. In this case, numsI is an integer, so it'll be the same as if I said sizeOf int. When we complete the call to write, the file marker also advances to the end of the data that we just wrote. That means that once we do a write operation, the next iteration of the loop starts at a new position, and we won't write over the previously written integer. It also means that we don't need to call the seek function to advance the pointer, because write automatically advances the file pointer to where it needs to be. And lastly, always remember to close the file once you're done using it. The second function, called tripleValues, is given a file stream which is open in input and output mode, also in binary mode. That means that we don't need to open the file inside of tripleValues. The file will be like the file that we just wrote with createFile, in that it has a series of integers stored in binary mode. The purpose of this function is to read all those integers, triple their value, and write them back to the same file. One strategy for accomplishing this, which is the technique that I'll use for this example, is to read a single integer, triple its value, and write it back to the file, and then advance to the next integer. Since I'll go through each integer one by one, I'll need a loop to perform these operations. The condition for the loop could be while not file.eof, which will continue until the end of the file is reached. But to get practice with random access operators, I'll get the length of the file and then keep track of where I am in the file and make sure I haven't advanced past the length of the file. Remember that the seekg function can randomly access any part of a file, and in this case I want to move to the end of the file, so I use seekg with the parameter of 0, which means an offset of 0, and the second argument is iOS end. So this function call will take me to the end of the file. The next line I use tellg, which tells me the current position of the file marker, and since it's at the end of the file, it'll return the number of bytes in the file. I store that in a variable called length. After that, I move the file cursor back to the beginning of the file, using seekg with 0 and iOS_beg for the beginning of the file. I use a variable called count to keep track of how many integers I've read, and then I see the condition in the while loop using random access is file.tellg, which is the current position of the file cursor, should be less than length, which is the position of the file marker at the end of the file. This slide shows the body of the while loop. So I declare a variable called value, which will hold one integer value from the file. To get the first integer, I have to use the binary file operation called read. And remember that read takes an address as the first argument, and that tells read where to store the value that's going to be read. Just like we saw with the write function for the create file function, the address should be cached to a character pointer because binary operations work on bytes. And just like with write, the second argument is the number of bytes that you want to read. Again, you can use the size of operator to get that value. Once the read completes, the file marker will be advanced to just after the value that was read. In this case, we just read an integer, which means that the file marker has been advanced 4 bytes, or the size of an integer. In the next line, we simply triple the value, and then we need to write it back to the file at the same position where we read it from. But because read advanced the file marker, we need to seek again to go back to where we should be. To get the correct position, I seek to the location count times size of int. So for the first time we read, count is equal to 0, so it will advance back to the start of the file. Once we're back to the correct location, I can use the command write to write back the value that's been tripled. Next, the count is incremented, and the loop continues until we reach the end of the file. In this presentation, we got some practice with binary files and random access. Remember that binary files have 2 functions associated with them, read and write, and they both take as a first argument an address which is cached as a character pointer, and the second argument is the number of bytes that you need to read or write. For random access, the functions seekg and tellg are useful for randomly accessing a file. Seekg will move the file marker to a location in the file relative to the beginning, current location, or the end of file. Tellg will simply return the current file marker's position. The position will be an integer that represents the number of bytes.